Test. Test. All right. So, yeah. Today is Dece 30. Yeah, got a big year coming up. Gonna graduate. And I really gotta step it up. If I can continue this year going deeper into the kind of genres that I've been working on, namely functional programming, I guess computer architecture, programming languages, then keep working on my open source projects. Should be doing pretty good. So yeah, I'm probably gonna be doing, or if I haven't done about 100 hours of streams this week, I kind of failed in a sense. I was like what I was trying to do. So enough talking, I guess. Just continue. So I'm reading Haskell programming from first principles. Here. I kind of wrote this book off as finished prematurely. For some reason, I was just trying to finish it. I cared more about finishing it than actually learning the content. Kind of a beginner's blunder there. But yeah, I've been catching up this last week, but I was kind of on break. I was on my computer, I just moved back in yesterday. Didn't really do too much, so. I think I left off on functor as function application. Let me refill my water, and then I can start this. All right. Need a jacket, bro. What's on my sleep schedule? It's clapped. Just a side note. Let's get into it. So functor is function application. So to catch up, so this chapter on functor. What is functor? It is a type class modeling function application within a context, I'd call it. So imagine just the $ operator. And this is just function application. You do sum, is sum a function? I think it's a function. Sum 1, 2. Oh, wait. Or I guess it's the plus sign, yeah. The plus sign 1, 2. Am I cooked? Oh wait, no, it's because I'm only applying it to one thing. So yeah, do this. I'm cooked. I'm so cooked. What am I trying to do? I think it needs to be in parens. 1 plus 2. Dude, what am I doing right now? I'm so cooked. Oh my god. Hold up. So I was trying to just show what it is, but now I can't even tell you what the infix $sign. Takes a function mapping A to B and an A turns B. There we go. So this is just pure function application. But in the case of functor, the kind of its argument, the kind of this argument is just type. Or k find. K? Can you not do that? K to get the kind. K functor. Oh, I guess you can't do it for. Wait, what am I saying find for? Let's say K false. Oh, I needed to Alright, I guess you gotta use data kinds to do that. But either way. Functor has this this kind that has an arrow. Whereas this just has false, or false and true, just have one star. And using fmap allows you to go like into this structure, just access this. I guess it's more of this actually. That's probably the worst explanation of all time. Luckily, because I haven't read the whole chapter, but yeah, just hopefully you just skip to what I'm talking about right now. Rip. Yeah, okay. Functor is just function application. We still have to try to make a function instance for a type class means so fmap functor. Give functor f. Function mapping A to B. FA to FB. There's also an infix operator, the $. $in. Carrots. I forgot I already read this. I already read this. I didn't read this. Probably stopped here. Why do we need a higher kinded f? We add a type argument to the data type from above. We make fix me please into a type constructor, and this will work. So now we have a higher kinded type because it actually maps an input type to an output one. Still won't compile as a functor. Okay, it will compile as a functor. No, we're actually implementing fmap properly. Fmap, just fix me. No function. It's just fix me. Fmap, f please a, please fa. So I'm up with the type of fmap. Yeah. Well, f is used in the type of fmap to represent the functor by convention. It is conventionally used in function definitions. Yeah, that is kind of complicated. I was calling this function for no reason. So you gotta have identity. Fmap ID equals ID. I mean, yeah, I agree with that. Second is composition. So fmap, f dot g, it's got to be equal to fmap f dot fmap g. Structure preservation. Yeah. Cool. Breaks identity, bro. Composition should just work. Yeah. Commonly used functors. T const. Interesting. Replace with P. Const P. I mean, okay. Solid. Data bracket A. Bracket or A append list A. Okay. F map replace with P. PVV. Replace with F PVV. So it's still like string FI, is it? Data comma AB is equal to comma AB. This would be 10, 20. Interesting. Negate 10 is negative 10. Toss him 1. F mapping plus 1 to negate. Toss him 10. Negate 10. And then your F mapping. The plus 1. Interesting. Hmm. This is level 1. This is like level 0. Level 1. Level 2. Level 3 is going in the actual strings with him. That's kind of cool. Yeah, I kind of implied the types that were going on there. I love the word modulo, dude. Think that makes sense, yeah? Get on up and get you down. We have a list of maybe list string. Let's see what this is doing besides just the same thing we did. Okay. Just LMLS. Nothing, just a list. So Haskell, just a list. Okay. fmap place with LMLS. So fmap in here, fmap in here. So just P. Nothing, just P. Go to another level, just PP. Just P. Another level. It's empty, so here. PP. Yeah, looks good to me. P function. So you got a functor F1 and a functor F of F1 of A mapping to F of F1 car. Yeah. Fmap, price of P. Maybe car twice lifted thrice. There you go. F of F1 of F2 is mapping to F1 of F1 of 2. F of F1 of 2. Car. 3 F master price of P. Same input, different output. Sussed out about this water, dude. My guess is you do 2A and or A. Like functor or A. I'm good. Yeah, that looks right. Functor identity, so given a functor f, eq f of a, map fa to a bool, f map id f equals f. Okay, so functor compose, eq f of c, functor f, given two composable functions, and f of a had a returnable. So here's your return functions and your functor. F map g of f map f of x is equal to f map g dot f of x. F map, sorry, g dot f bracket x. Cool. Carl arbitrary. Yeah, I don't like doing exercises, man. Fine. Syntax. What is this? Oh my gosh. Let's look at the answers later. You got time for all that. Hmm. Curious how the inverse of this works. What happens with all the elements in the list? Right. So functor took. Oh my gosh, that took an hour to read that. Dude, that's crazy. Did I like go to the bathroom for 30 minutes or something? Like, what? How did that take that long? Oh my gosh. That was 50. This is another 50. Then monads 40. Then it's 30. Parser combinators. Oh, that's gonna be dope. Okay, I gotta read this, dude. Oh my. Dude, whoever made time finite kind of messed up. All right, applicative. Seen two algebras. Monoid. Mash two values of the same type together. What is monoid again? That's the M concat. Oh, let me look back at monoid. I kind of forgot what that is. It's a binary associative operation with an identity. So like, what's this? It's a class. So it has M empty, which is just the used to define the identity function, and then M concat, which takes a list of something and converts it into. I'm gonna keep it going. Dude, what? The monoidal functor. Come on, bro. Allows for function application lifted over structure, but with applicative function is also embedded in some structure. Because the function and the value it's being applied to both have structure, we have to smash those structures together. So applicative involves monoids and functors, and that's pretty powerful. Define and explore the applicative type class and its core operations. Demonstrate why applicatives are monoidal functors. Make useful chit chat about laws and instances. Do a lot of lifting. Give you some validation. Defining applicative. The first thing you're going to notice about this type class is that the F represents a structure similar to functor. So class, you already have a functor. It's constrained by functor type class. Class functor F, applicative F, where pure A is maps to a functor of A. Okay, and star. TIE Fighter or AP? App. Are we calling this app? So functor of a function mapping it. You take a functor of a function. It's like taking a list of functions in a list. Oh, okay. I think that's solid. It's like taking a maybe function and a maybe A. Doing the maybe B. Or a list of, I think the list of functions to list of A's and applying them and then having a list of all the B's. That makes sense. App. So functor F takes a function. So now applicative just has a new thing where the function mapping these A's to B's with is also in the same functor. Or I guess it's in the same applicative, yeah. But it's still a functor as well. I've seen this lift A many times. F of fx equal to pure f app x. Plus one. So pure just lifts it into the list. This is like making a list of functions that are all the same. Plus one, yeah. Pure one. This one. Pure one of type maybe int. Pure one of type either a int. Pure one of type list of a. Tuple list of a int. It's the same thing, but it's just the right. Monoidal functor. Let's notice something. So functors on the arguments, functor on everything. So how is it monoidal? Monoidal probably means what happened to it being a binary associative operation with an identity? What happened to that? Take the headphones off and make my head way less because my neck is super clapped. Also, I might go get a little sody pop from the downstairs. Yeah, I'm gonna do that. Take a break. I'll take a break at the next stop point and do that. So how is this monoidal? I have a functor and a function. Functor A mapping to functor B. This makes a ton of sense, in my opinion. If you just look at it as a list of functions. But we'll soon see that debunked. Two arguments are a functor of function and functor A. We just applied A to B and A to B. Still a problem as we need to return FB. And we're doing with fmap. We had only one bit of structure, so it's left unchanged. Now we have 2 bits of structure of type F that we need to deal with somehow for returning a value of type FB. We must unite them somehow. Now they would be definitely the same type, because the f must be the same type throughout. In fact, if we just separate the charger. Yeah. Didn't we have something earlier that can take two values of one type and return? Ah, yeah, visual. Provided the f is a type with monoid instance, then we have a good way to make them play nice together. Just mapin them. Хорошая idea. Yeah, okay. I see that's monoidal. That's what shit. So the applicative we have a monoid for a structure definition. That's never said. So with applicative we have a monoid for our structure and function application for our values. You just imagine lifting the mappend into this context. And then it's just function application. So in a sense, we're bolting a monoid onto a functor to be able to deal with these functions embedded in an additional structure. In another sense, we're enriching function application with the very structure we were previously merely mapping over the functor. Yeah, okay, this is kind of dumb. Let's consider a few familiar examples to see what this means. So yeah, this is like the list of functions. So you have a list of functions times 2 and you're mapping it with 4 or 5. So let's just write this for an exercise. You could say, so let's make 2 functions, do times 2. You can even do plus 1. Fun. And we're going to fmap this. Sorry, we're going to AP this. Just a list of 1, 2. Awesome. Alright. So what was this AB enriched in with F, A to B, FA, FB? In this case, listness, yeah. Well, the actual application is quite ordinary. Now I have a list of functions rather than a single function. But listness isn't the only structure. See, I don't really understand the just function. Maybe. Makes sense. I guess it's useful for nothing if you want to like conditionally do a function. Yeah, okay, that makes sense. That's kind of cool. With maybe the ordinary function mapping over the possibility of the value's non-existence with applicative, not function also might not be provided. Nice long examples of how this might happen. How you can end up with not providing function validation, not with either in a new chemical validation. I'm hyped to get to monads. I'm not too worried about these next 5 chapters, but parser combinators. That's pretty dope. Taking compilers this semester, I'll probably write mine in the Haskell. Opposing types. Monad transformers. Yeah, I need to learn monad transformers. Non-strictness. I think I already understand this from parallel and current programming in Haskell. Basic libs, certainly useful. IO. Dude, IO being the last chapter is crazy. That's wild. Show me the monoids. It's gonna be a good place to stop. Show me the monoids. Tuplet monoid. Let's stop at applicative and use. So show me the monoids. Recall that the functor instance for the 2 tuple ignores the first value inside the tuple. Indeed. But the applicative for the 2 tuple demonstrates the monoid in applicative nicely for us. In fact, if you call info on the comma operator in your REPL, you'll notice something. Data comma AB instance, so applicative. Instance monoid A. Applicative, the functors comma A. It's on the left. Am I bugging? Am I bugging? We don't need a monoid for the B because we're using function application to produce the B. For the applicative instance of the 2 tuple, we don't need a monoid for the B because we're using function. We don't need a monoid for A because we have 2 values and we need to somehow turn that one. Okay. Yeah, okay. So we have a tuple with the woo +1. Whoa, that works. It's just hooking into the string monoid instance of append. I guess it's concat. That's kind of surprising, actually. Uh, uh, what's the monoid? Monoid for string. Yeah, I guess it's just appending. That's kind of interesting. Or I guess it's just the plus plus, yeah. What do I do? I thought it would have been like an instance of monoid or something. Data monoid. So we have a tuple with sum 2. Ooh. Ooh. mm. That's kind of clean. Wow, that's kind of cool. Kind of mess with that. Dang, that's kind of dope. The operation is like embedded in the monoid. Kind of dope. Sum 2, and you got +1. App, that's some 0 and 0, and this just applies to mono. Wow, that's kind of dope. Wow, that's kind of crazy. And yeah, the same with product. So, yeah, the monoid is defining like a binary operation that's associative and has an identity. So, okay, well, that's kind of crazy. All true. Don't recall what all is, but yeah, I mean, I understand the premise. Tuple monoid and applicative side by side. So imagine you have two monoids, and we're making a monoid for the tuple. Mempty is just mempty. AP is append A prime P prime. P prime. Sorry. AB append A. Okay, so appending them is just like it is like has a lot of composition. Okay, because it's just monoid and hence has an identity. Okay. Monoid A and applicative is just the same thing. It's sort of saying pure X is empty X, UF, app, VX, UMAPM, VFX. So understand this. I kind of forgot why it's FX here. Oh, it's just function application. Perhaps functor application. No, this isn't a functor. It's function application. Okay. Just function, just a. How does it know that F can be applied to A?
Or sorry, A can be applied to F. Alright, I'm getting a Bev. Applicative in use.
Applicative in use. Dude, why is it so cold? Or by synthesizing. Sorry, specializer types.
List of functions, list of A's, and list of B's. Pure A, FA, list A, so it's just a list of A, yeah. With the list functor, we're just mapping a single function over a plurality of values. Now we're mapping a plurality of functions over plurality of values. So I'm still a bit confused how the first argument, or sorry, the first value in this
Can be monoidal. It's like a monoidal application. Is applying the monoid? Whereas the second one is just applying the function. If we go back to having that sum type, is that like a global thing? Or monoid data to monoid sum to. So if we like pinned sum 2, sum 3, get sum 5, get sum. But if we do a tuple, if sum 2 plus 2 AP 2 can be sum 2, yeah. Sum 2 2. But can you invert it? Plus 2 sum 2 AP 2 sum 2. You can't do that. You can't do that. Yeah, that part I don't really see why that's the case. Like, what is the utility of that? But whatever. Or is this because we're doing sum 2 with 2? I feel like errors in GHC are kind of trash. Dude, this guy is so cracked. This guy is so goated, dude. Haskell blocks. Dude, shout out. Dude, that's so crazy. Dude, shout out SPJ, bruh. Shout out SPJ. There's a lot of Haskell books, but they're all like this. There's too many like beginner Haskell books. There's not enough. Texas hold up. Haskell books. Certainly it's not counterfactual regret. It's kind of very niche book there. Categories in Haskell. Learn Haskell quickly. Things I wish I knew before learning Haskell. Haskell for beginners. Algorithm design. This is kind of curious. Algorithm design in Haskell. I'd rather just kind of read a book on functional algorithms in general. Also, that cover looks like Scheisse. Retro computing with Clash is kind of dope. Yeah, that's kind of crazy that exists. Book of Monads. Okay. Haskell and Weichenschlüssel. Physics with functional. Effective. SOAR. Pragmatic type level design. Sounds somewhat useful. And it's language agnostic, it appears. Or it's Haskell. First edition. Book samples. Chapter 1. Chapter 1, P1, V2. It's just code. Okay, I'm not really sure what's going on there. Mathematics and programming from this person. Looks pretty good. Chinese media press. Just a cover check. I kind of like that. Infinity. That's kind of interesting. Mathematical foundations of computer science. Category theory. No, I'm kind of curious. Provided by Georgia Tech Library. Oh. Table of contents. You got front matter. You got numbers, recursion, symmetry, category, fusion, infinity, paradox, black matter. Huh. Might add this to the see if there's any good. Alright, search out. Book title is a bit generic. Is it math for programming? That's something else. Huh. How backlogged am I right now? That's the question. Category theory for programmers, practical squeal, static program analysis, logical foundations, compiler optimizations for scalable parallel systems, TSP. Yeah, I got a lot to read, dude. Boolean. We'll pause for now. Concurrency. I have this. Gotta work through that a bit. Popularity of programming languages. Python? So trash. Dude. What? I'm not gonna take your list properly if it's C/C++. Might as well have done Java/JavaScript, dude. Rust at 9 is crazy. VBA? This is BS, bro. VBA. You're bugging. What? Okay, this is certainly false. Code blocks. Dude, nobody uses Sublime Text. PyCharm at 10? Nah. This is not right, dude. I'm sure I feel like VS Code is way more popular than Visual Studio. Dr. Java, Monkey Studio. Dude, this site is trash. Oracle DB at 1 is wild. Yeah, this site is trash, dude. Oh, this site is actually cheeks. PHP at 7. C Sharp at 5. Objective-C and Swift. Go at 12. Cotton at Ada. Ada at 15? Nah. Nah, bro. Ada above Lua, Ruby. Haskell at 27. Delph. Dude, this site is trash. Site is actually rage banned, dude. Can't say this looks like the best game I've ever played. No disrespect to you. Shout out Romaz, dude. Yeah, so I gotta read a few more chapters to understand that. Yeah, I don't see why everything must be so pragmatic. But that's true. That is just part of programming languages. Even like a very much worse language like Gleam. Get up Gleam. Get up Haskell. Just looking at like, I guess you can't look at the traffic as easily. But something as huge, I'm sure GHC is on area. What's the main repo? Stars, S1. Oh, I guess it's just the language server. The amount of traffic between these, like the number of forks, watching stars. 1.7 out? Sponsors even. Excuse me. There's just a lot more going on, even though this language is barely usable. Just more hyped, I guess. I really don't know a single person using this. Like, is it the amount of people at how many CS students? Georgia Tech CS enrollment. So there's 14,000 graduate students. Freak OMSCS. But fall 2023, there's 5,000 undergraduate students. How many of them have spent more than 20 hours in Haskell? Probably somewhat similar to the amount of people. I'd say maybe 10. I mean, probably even less for Gleam, but and Erlang. I don't know. I don't know if I'm saying anything particularly insightful. I'm just talking. But yeah. Also, how are we number 2 for cybersecurity when we didn't even do anything about cybersecurity? Number 3 for software engineering. It's just some bullshit. 14 for programming languages. 14 for programming languages, and we have one class on programming languages. Dude, what? That's just wild. And the undergraduate research opportunities program doesn't even exist. School is overrated, dude. So, like, how much is Haskell making on Open Collective? HOS. A lot from Mercury. But Mercury just made its own, though. Gitpod. Got a K from Ganesh. Shout out Ganesh. I've heard of well typed.
Yeah, I've heard of this dude. Yeah. It will be curious to see how programming languages evolve. Things like Rust could see getting kind of large. There's so many of them. I don't know. The main thing with Haskell is like no one wants to read 1,000-page book to learn programming language. And no one wants to read a 10-page paper to do it. Yep. You know, dang. This guy is just crazy. Yeah, the error, Rust's error, and just like build tool error formatting, just the whole like cargo command line interface. Yeah, that's real. This guy's good, dude. Wait, the heck is that? It does kind of make newbies feel dumb, Bucky. I guess that's the point of having like map. I don't know. Like you hear about, oh, you have map. Like why not just have fmap? It's because like the error message is talking about lists and not functors or something. Okay, I mean this guy's needs to chill out a little bit. Like you're not really that special, bro. Erlang prob. Space Geek. Okay, this guy needs to chill out. I mean, variable not in scope X is like a pretty trivial example, though. Like error messages that are not gonna be better is like this. No possible cause. Sum is applied to too many arguments. The expression sum 2 over here. So sum is applied to too many arguments. Yeah, I don't. I mean, it could of course be. I mean, I guess it is a skill issue, but like, I don't really see what this. Like, I really missed the rusty. Oh, you got an arrow coming in here. Hint. Add parentheses. Even like in request. So, uh, I really don't think Haskell will ever be some huge language, just because like it's very hard to use. Like writing a project in Haskell is freaking impossible. Even compared to writing it in like C. It's my opinion. Getting the build tool to work, getting the LSP, getting Cabal stack to work, LSP to work, Docker to work, Docker to getting to work, Docker to work, and AIDS. Yeah, Haskell build is horrible. But let's move on. Alright, let me close this out so I quit looking at it. But yeah. So it maps each function second list, provides the operations. Use the tuple constructor. The list applicative. So we're putting these on a tuple. 1, 3. Applying this function to this. F mapping it with this. Lift A2. Lifting onto this applicative. First one I lifted in there, third one we apply it to this. Plus fmap this. So it's +1 and +2. Okay, it's +1, +1, +2, +2. In other words, lift A2 plus max fmap. So it's max 1, max 2. So it's going to be 1, 4, 2, 4. Lift A2 max. Look up. EQA, A and a tuple AB. Ah, okay. Okay. It's got map of sorts. Map of sorts. Look up 3, the key as well. Fmap length, look up 3, hello. Fmap. So I guess it could be multiple. Or it's maybe, so it's mapping it. Okay, so it's mapping it into this maybe. Fmap length. Look up 3. 3, hello. Let's see x append x's. 2 upper, x append x. 2 upper x append x's. Yeah, okay. Fmap c. Look at 3, 3, hello, just a 1. It's worth pointing out here that if you're working with map data structures instead of list of tuples, you can import data.map and use the map version of lookup along with FromList. FMC data.map.lookup 3 from list 3 hello. Two maps, looking up X, G, look up Y, look up Z, look up MX. F3. Hello, G8, Chris. Plus plus, Fmap, F3. So Fmap, what is F here? So F3 will be done first. That's hello, so plus plus. So it's going to be hello plus plus sub question. So plus H5 M1, so it's going to be whatever the two numbers are. Plus H5 M6. 6 doesn't exist, so it's nothing and then nothing. Okay. Lift A2. So I can just rewrite this as lift A2. Identity. So let me 664. Don't care about that. Maybe. Skip. I'm skipping all that. Skipping all that. Applicative laws. After examining the law, test each of the expressions in the problem. Identity. Here's the identity definition of the identity. Definition of the identity. Pure ID, APV is equal to V. Pure ID. So it's just going in there and IDing this. Let's see what this does. Pure ID AP plus 1, 2. Plus $1.2. Pure ID. I'm not sure what functor that's lifting it into. Lifting it into this. And then we're going in here. This is plus 1. 2. Okay. Pure, yeah, okay, that's good. It does the same thing as fmap, but it loads this into the same context as this. Yeah, that's chill. Composition. Pure composition, APU, APV, APW is equal to U, APV, APW. I'm gonna say that's okay. Homomorphism is a structure preserving map. Categories. Yeah, I don't care to be a pro at this in particular. I just got a lot to do, and one of the things is just getting this book out of my function. So pure f, so loading this into a context. Pure x. Pure f, yeah, okay. This is just like kind of inductive from the monoid being having identity and the functor being composable. Kind of a guess. I guess it's just the monoid being applicative, like I said. Because the structure isn't doing anything. Interchange. U at pure y. Pure y, yeah. Function embedded in some structure. Oh, yeah, the function is function application is crazy. Quick checking them, I don't care. Zip list sounds important. From 0. Either versus validation. You could have more than one valid monoid for a given data type, unlike functor. Applicative can have more than one valid since for a given data type. Yeah, okay. Following is a brief demonstration of either, pure 1, either e int, right 1, right plus 1, AP right 1, 2, right plus 1, AP right left, this, this, left this, right this, left this, this. On validation. Validation error A, failure error, success A. Kind of smart. That's kind of useful. I need that in my chapter exercises. Monad. All right. So it's time for me to end the stream and go to the post office. Haskell functor applicative.